the one and only Neri Oxman. Thank you.
Thank you. Close your eyes. Follow the man with the orange shirt. That is what they tell you. There was no particular map to follow, and there was no way for you to know where you'll end up and what you'll be seeing, or how and what you've experienced might affect your consciousness or your tomorrow's dreams. So you followed the man with the orange shirt. You wandered amongst cameras that see through you, neurobiological contraptions that can read your mind, landscapes made of bits that can anticipate where you are going next and how you're going to feel about it, viruses that are good for you, silk tattoos, a robotic arm that spits out a house, a radio woven from evergreen bark, pixels too coy to cut through matter, but present enough to simulate Earth's rotation, Simon Power's uploaded memory of his days of youth, a media revolution, a food processor counting your carbon footprint, an eyelid made of photosynthetic cells, a breathing skin, a printed clock, a chair that grows, soft omnidirectional robotic cars, robots that care for your children's education, and a vibrating harp that brings you back to the now. Open your eyes. You're back, awoken, astute, hyperly networked, inside and out. And you have no idea what the man with the orange shirt is going to do next and where he's going to take you. So, this is the cover of Naked City, the Society of Spectacle. It's a book that came out around 1950s, so mid-1950s, by Guy Debord, the founder of the Situationist movement, who coined the term dérive, the idea that through some kind of unplanned journey, you can understand the world that is around you, the world of matter. The world of matter that consists of urban scapes, cities, products that you touch, areas that you move through, everything that is physical and also immaterial in the city. In fact, he contributed to the French New Wave in cinema as well, and also inspired lots of urban designers. So really in urban design and in making or constructing an environment and moving through physical space, Guy Debord argued there's much more value in moving through the space of experience and in designing that space of experience than in moving through this hierarchical map that tells you where to go from one point to the other. And so this field that essentially was born out of contemporary Paris, 1970s, was called psychogeography. And psychogeography was, and I'm reading, the study of the precise laws and specific effects of the geographical environment, concisely organized or not, on the emotions and behavior of individual. A whole toy box, toolbox, full of playful, inventive strategies for exploring cities, just about anything that takes pedestrians off their predictable paths and jolts them into a new awareness of the urban landscape. So this was Guy Debord's dérive. And so since the theme of this session is really from the psychological to the medical, and networks are everywhere, really in designing urban spaces and also in designing products and designing ways of designing things, networks and horizontal networks are all around us. So from the social space of the dérive to the biological space in the natural world. Networks in the natural world, most of them are coined the rhizome. And so the rhizome is an underground horizontal root system that grows, that is separated, when separated to pieces, can give rise to a new plant of the same kind. In the 1970s, a good friend of Guy Debord, Gilles Deleuze, also a French philosopher, there's a lot of French philosophy, new structuralism is coming back, he developed the rhizome as a philosophical idea to coin a horizontal image of thought, design and social collaboration. So from social to biological constructions. Now in design, and I'm an architect and designer, and when we design and when we look at the environment and when we're designing things and making things, we're designing experiences as much as we're designing those particular physical objects. So from root systems to the design of cities, the cities of the vernacular, cities that are informed and brought about by social and natural forces, to even the description of cancerous cells, right? They are all rhizomes. There are all those horizontal networks, both in the social context as in the biological and natural context, that repeat themselves. So a few notes about what we do at the Mediated Matter Group, and we're located at the Swatch Lab on the 4th floor. Some of you have already visited us. And I wanted to talk a little bit about where we started. So less than a product-oriented group, and there are lots of separations between product and process. We're very much a process-oriented group, a group that looks into processes of how to design things and how to make them, how to actually fabricate them. And so we design networks, and we design those networks as parametric tools. And those parametric tools, when set up in a particular network organization, might produce a particular form. And when set up in a completely different organization, might generate a completely different form. And when placed in a spatial context, in an actual, say, architectural context, they might generate a space. So from social, from the design of urban spaces and bringing the dérive into the urban context, to the rhizome, to trying to look at biological systems, how do these principles translate into the world of the artificial and into product design? A few examples from product design, medical design, and I'll end up with the design of actual fabrication technologies that inform the way of making those things, are also very much informed by networks. So networks and product design. Beast was a chaise lounge that was designed to wrap around a human's body. So it was designed to fit and be customized to a particular human body. It's 3D printed from 5 or 8 materials, depending on the model. And those materials change their stiffness and change their softness as a function of the load that's simulated into the form generation model. And so the system, the particular network of a process, is embodied in the network of the product, the network of which is comprised, in this case, of 2 materials that are changing in stiffness, changing in softness, black for stiff, white for soft. And depending on the load, you can change the density of those structural components, their thickness, and their distribution. So this is the chaise lounge. And the idea really was to create one continuous surface that would vary in stiffness to account for the different loading positions of the body. Contradictory to modern design, this is the chaise lounge by Le Corbusier from the early 1920s that operated by rules or by logic of design assembly. That's very, very typical of the modern movement. We're now looking into biological principles and how they might affect the world of making, looking at material distribution. Material assembly, material distribution. Assembly, distribution. Assembly, distribution. Carpal skin also looks at the distribution of pain and how the distribution of pain might be translated to the distribution of materials to support or give comfort to the patient. So rather than looking at the anatomical position of the organs or at the geometrical articulation of the organs, we're looking at the body as a dérive. The body is a map of points that can all be networked to then be translated into this material map that would find its expression in actual designed form. And so, again, rather than designing a wrist splint that's made of fabric to support your hand with a particular assembly of a splint in the center that would constrain this kind of movement, we could control the gradient of those materials as prohibiting, constraining, or motivating more movements that are customized to the particular pain profile of the patient. So the patient unwraps or underdevelops this wrist splint and can literally paint those paint maps on top of this undevelopable surface that's here developable to allow the patient to compute their paint maps into materials. And so the actual glove, again, instead of being made out of an assembly of fabric and of a splint, is made of this continuity of material that changes in stiffness and softness and humidity and temperature, potentially, to accommodate for these various paint maps. Material assembly, material distribution. So from the design of products to the design of medical devices, to the design of technologies that can support these designs of products and medical devices and potentially buildings. I'll die by this theory, and I'll live till I can I actually create a building by this particular theoretical framework. How do we go about designing machines, designing tools, designing technologies that can assist us to make things in a revolutionary and a radical new way? So this is what Mediated Matter Group is dedicated to. And just to quickly move through three very, very quick projects. The skin in my face is very, very thin. It's made of pores that are relatively large, as opposed to the pores in my back. My back is made of thick skin, much thicker skin. The pores are much smaller. That's because the organ, the skin, is made of the same system, and I like the graphite diamond analogy. It's made of the same system, but is structured differently depending on the type of thermal or environmental performance that I engage through my skin and through the environment in which I'm exposed to. And so the skin, again, made of graphite and diamond, made of carbon, both of them, but depending on the structuring of the material, completely different product. Same material, different reorganization and structuring, completely different product. And so how might one go about 3D printing a product that's not made of an assembly of materials brought together, but a continuity that changes as a function of this mapping of structural performance, of environmental performance, and imagine really your computer being tied to a finite element analysis that's measuring the load that you're applying to the particular ground and immediately translating that force into the generation of a product, a building, a system, a medical device. What does it mean to generate those gradients in a particular additive fabrication platform? What would it mean to design a concrete beam as if it was my femur? My femur is made of calcium. The calcium is constantly responding and remodeling itself based on the loads that I introduce to the bone. The magnitude of the load, the direction of the load, the distribution of the load. But as I cut through a section, a beam in this building, it's filled with concrete, homogeneously distributed concrete, and lots of concrete that goes to waste. What would it mean to come up with a completely new fabrication technology that would be implemented not only in product design, but also in architectural and construction design that would save between 0.1% of concrete to 40% of concrete, depending on how we do it? So we've promised to repurpose our robotic arm, and so we did, and you can come and see it in our space. Stephen Keating, a researcher at the Mediated Matter Group, has been really leading this effort charismatically. And this is the robotic arm that's now converted into a 3D printer. And now we're working on mimicking the palm trees and the bone, cellular materials, and arriving at those various densities spatially and materially and also chemically. Assembly, distribution. So more projects in the Swatch Lab on the 4th floor. Stephen Keating has also been working on jammable matter and looking at how jammable matter, jammable materials can respond and adapt to various structural and mechanical loads. Liz Tsai has been responsible for the design of the artificial tissue three-dimensional printer, the variable elasticity printer. And Ben Peters is working on a magnificent pin tooling mechanism that also adapts to the form and the shape of the product that's inserted into it. So I'd love for you to come and visit our space. And with that, I thank you for your participation and your being here. Thank you very much.